Okay, welcome everybody. Hi to this talk about kind of the hands-on version of how to, I don't know, observe, monitor, but I don't really want to dive into the differences of observability monitoring. There was a talk on that on Wednesday already, so I really want to give a kind of hands-on talk about what to do when you want to monitor or check your stuff, basically. So I'm Philip, and I'll just give you a very short introduction with slides, and then we just jump into it hands-on. The entire idea to this talk came when I saw that tweet. And I think that is a very nice idea. Like once you're going from your big bad monolith to anything distributed, stuff, especially around monitoring, gets much more interesting. Because it's like if you like, I don't know, a bit of crime and you want to get some clues and traces here and there, then that might be a lot of fun. But if you just want to have something working and you want to know what is going on, stuff can get a bit harder. So if you enjoy murder mysteries, do whatever you have been doing. You can still use SSH and tail if this is what you like and you find a trace here and a bit of information there. But if you don't want to do that, that's kind of the idea of this talk, to just see what else you can do. If you don't want to stand, we have a lot of seats over here still, so just move on up if you don't want to stand at the corner. So I guess a lot of our applications are something like this. You don't have to show hands who thinks their application looks like this, and you're still in there and thinking, well, this is all fine, until at some point it's not really fine anymore. And some are probably in that state already, where you realize, well, nothing is fine anymore. And that we don't get to that point, that is kind of what we want to get to in this talk. And this is the last tweet, don't worry. Sam Newman, he's also very big in the microservice ecosystem. He said, like, the first thing you will need to do is you want to have some aggregated logging, and then you probably want to correlate information and see how requests are flowing through your system. So just quick show of hands, who is still using SSH and tail or less or anything? Okay, that's quite a few. Well, you came to the right talk. At least as soon as you have more than 5 servers or services, that's probably not what you want to do in the long run anymore. But we'll get into that. So kind of the idea is we want to log and monitor all the things. We just want to dive in and see what we can do here. So why am I talking about that? I work for Elastic, the company behind the Elastic Stack, what previously was called ELK, for Elasticsearch Log/Cubana. So we have added a new component. We'll mainly focus on that new beats component today. That's why we kind of try to get rid of that ELK and always try to call it Elastic Stack, also to strengthen the brand. I'm part of our infrastructure team, so we do a bit of the internal tooling, Docker containers, AWS, any internal service we run. And I always say this is a Unix pipe. I kind of piped it out into developer advocacy, so I speak about all the good stuff that we do. So this is not a real application that we're using. It's a very highly monitored Hello World application. And you can get all the code and try that out all yourself. And we'll do it totally interactive. So this is running on AWS. So you will be generating the requests for today, if the Wi-Fi is playing along, let's hope. So I've already asked who is using SSH and tail. Let's skip over that now, and let's get into the action, what we'll do. If you want to get the code, that is where it lives. I'll have the URL at the very end of the slides again, so you can just check it out and then take. That is the one picture you might want to take. I think the slides are linked from there as well. So that is where you can kind of like get the actual content of what I'm showing today. Because I won't go into too much of the code details. I will just use a very simple application and then just start to monitor it. So I will use an application. I'm using Spring Boot, but there's nothing really particular to that. It's just something that communicates internally over a REST API, or just basically it's HTTP calls and sends a bit of JSON around. That's all there is. And I don't want to go into any microservice discussion either. Time is too short, and there are lots of other talks about that. I just want to cover the monitoring side. And I keep this very simple. So there is no discovery, load balancing, whatever. And some might say, are these really microservices then? And I always say, well, my definition for this talk will be very short names are also very micro. So that is my microservice definition for today. And with that, we'll move beyond that whole microservice thing, because I feel it's getting very tiring that everybody's repeating what it is or what it is not. And of course, we run it in the cloud, since everybody needs to have some cloud in there. So I'm using the cheap AWS servers, Lightsail. I configure everything or provision everything automatically with Terraform, and then I configure and deploy my application with Ansible. It's all in the repository. I won't dive into that, but if you have any questions around that or want to check it out in more detail, the repository is kind of your source of truth for that. And we have our own cloud service. That is where I will run everything since I'm kind of lazy. I've just spun up an Elasticsearch node and a Cubana node for that, and we'll just run everything out of that. If you want to run it locally, I've once heard that you need to mention Docker in every talk. We have done that now. So if you want to run it locally, you can totally run that on Docker as well, but we'll try to run it online so you can actually interact with the service today. So, and I will focus on the open source component. So whatever I show you, you can just take home basically and use for free right this afternoon. So that is kind of the stack. If you've seen our logos previously, they were kind of different. Our Photoshop skills have improved a bit, and it's kind of like more similar across the products now. So we have Elasticsearch at the very center, and it's the oldest product where kind of we store all the data and you query it out. Then we have the beats, which are like lightweight agents, shippers, forwarders, whatever you want to call them. They're written in Go, so you get native binaries, and they're as efficient as they can get. And they will collect various pieces of information, and they can either forward stuff to Elasticsearch directly, which we'll do today, or you could still push stuff to Logstash, which could then do some parsing and enrichment. But we don't really need to do that, and to keep it simple, we're just skipping Logstash today. So the beats will push data to Elasticsearch, and we will then visualize and see what is going on through Cubana. And that's pretty much all we will do. So let's start with some monitoring. And I will just open Cubana. So throughout this talk, it's very small. You probably cannot see the URL, but it's Xiara, which is also my Twitter handle. Anybody guessed where that Xiara thing is coming from? It's if you take my last name and rotate the letters by 13. That's the good old ROT 13. And the nice thing about ROT 13 is like encryption and decryption is the same, because if you rotate by 13 again, you get back to the original. And then since it's a demo, the domain is WTF, and I thought that's kind of the right URL for a demo. If you go there, you will be logged in with a different user which can only see the dashboards, but you can try that out later on as well. I should be logged in with my Philipp user now, which can see a bit more, and I'll make this slightly larger. If you've never seen Cubana, this is Cubana. If you're wondering, and this is slightly cut off on the left-hand side, which don't be too confused by it. It's like slightly cut off, but you pretty much see what is going on here. If you're wondering what version that is, I always say it like that 3 was black, 4 was white, 5 was colorful, and this is the upcoming 6 version. That one is blue. So we've heard that if you're colorblind, like that colorful stuff was not working out well, and that blue stuff is better for colorblind people and accessibility in general. And this is the second release candidate we have of that. So the entire stack will come out in version 6 very soon. Let's see how many weeks, but it will only be weeks. So bear with me if anything fails. This is a release candidate. It's not a final version, but it should be reasonably stable already, hopefully. Let's see. So that is what you get at first. You can see some data that we have stored here, but I'll jump to something a bit more graphical right away. So we have, let me unfold it again. So we have the discover thing where you basically see documents that you have stored, visualize where you can either see pre-built visualizations or build your own. And then the dashboard is where we put together multiple visualizations. And all of these dashboards here are pre-built. I've simply imported them. So I'm lazy, and you can be lazy too. You don't have to build all of that yourself. You can just import it. And I will start very simple with my monitoring approach. I will just start on the system level and see what my system is doing. So I will switch over to that overview page. And you can see here, I have 3 nodes in total that are running. You can see they're using some resources. Basically, what you're seeing here is the last 15 minutes. Let's turn on auto-refreshing because, well, whatever happens, we want to have it auto-refreshed. Yeah, you can see, okay, histogram of CPU usage on the nodes, like most of them were pretty idle. And now we can jump into the application and do something. So I will connect to one of my nodes, and I will let's say I'll start the typical Java program. So it basically allocates memory until it runs into an out-of-memory exception. So it's just doing what you would expect. So let's give it, I don't know, give it 400 megs of heap and say jar, and I have it in opt, and I called it bad jar. So really all this does is it will allocate memory until at some point it will crash with an out-of-memory exception. But this is a feature now. And with the auto-refreshing, we might already see it here, and you suddenly see, oh, that is already turning yellow here. That is unfortunate, and now it's red. So you can already see that here something is probably up with that instance. And you know, that is the one instance probably where we started stuff. We have already also a host overview page, which will default to one host here, but if you put in a star here, you can see all of them. And then it will give you kind of the overall view of what is going on. And then you would see here, the red thing is the used one, and it's kind of weird since it's not growing up, but kind of growing down into the green free space. But you can see here we had this kind of blip of where we were using more memory. And now we could try to dive into which specific node that was, but we can also build something on demand now. I don't want just to show you kind of pre-canned stuff, but we can just build a new visualization. We've added a new, so these are all the visualizations you can use in the current or upcoming Cubana version. And we have something new called Visual Builder, where you can kind of click together a bit more of a powerful visualization. So you can see by default, you will see the number of documents we have stored in Elasticsearch. But I'm interested in the memory now. And I don't want a count, I want actually a sum. And the field I'm interested in is called system memory, and then I think it's called used bytes. And now you can see, okay, we have some high value, but that's not that helpful yet. So first thing I will do is I switch from number to bytes, and then you can see, okay, overall memory usage overall in my nodes is 1.6 gigabytes. Only here it jumped to 1.9. But this is aggregated over all the nodes. So maybe you want to see about specific nodes. So what you can then do is you can say terms, which is kind of an Elasticsearch term, but you can just split it up on the host name, for example. So I have, since the beats are collecting that, the beats are picking up a nicely human readable host name here. And then you can say, okay, split it up by 3 instances, and then you can see, okay, this was whatever every instance was doing, and then you suddenly see here, okay, the front-end instance was suddenly using 870 megabytes of its 1 gigabyte. So something was definitely wrong here. And then you might want to investigate. And then you probably would find out at some point when you look at the process list, okay, something was up with that application. And yes, it died as it should have. Okay, moving on, let's get to our actual application. And you can totally follow along. So whoever has a mobile phone here or a laptop, you can just do some requests as well, because we will monitor those. So you can just go to Xera, which is XERAAW.WTF. And if you open that, you should see this page. So grab your phones and open that, please, if you can, because we will monitor all the requests coming in here. And you have various links what you can do here. So you can click on, you can get a 200, which, well, just gets a 200. You can do a get with a parameter. So in the URL, you have a name. Instead of Philip, you could put in your name, and we'll probably find your name afterwards, or whatever name you want to have here. For example, you could name that Peter or whatever. You can get, I don't know, null pointer exceptions. I throw various exceptions so that it behaves like your application, or maybe not your application, but somebody's application who throw exceptions. We can get a 400, so we'll do some requests. And now we want to see how our application is doing. And the first kind of layer or angle from which I want to take a look at that is the network. So we have another beat. So I didn't really specify that. The previous beat we call metric beat because it gets system metrics. One of them is, well, like top or free memory or whatever. That was the previous one where I showed you how when I used memory. Now the next beat I want to go into is packet beat. So packet beat is pretty much like Wireshark, is using the same base library libpcap just to listen in on the network interface and collect information what is going on there. So if I jump over to my dashboards again. And this time I'm interested in packet beat. And then you can see, okay, we have an overview page. Let's jump to that overview page. So that overview page will just show you how many requests you have done. Since I don't have a cache or a database running here or RPC system, we could monitor those as well, but I just have, well, web transactions or HTTP here. So thanks for the requests. You can see like we did very few, and then you jumped in and we got up to 100 or 200 something requests here. You can see like how many requests you had in total, and the color is actually telling you how long did they take. Like that would be up to 10 milliseconds, 10 to 20 milliseconds, etc. You see response percentiles. So most of the requests were pretty fast, but you see 99th percentile was up to 3 seconds. So maybe some users were already pretty unhappy. You see success versus error rates. So most of our requests were okay, but some failed. Down here, you can actually see what kind of errors did we get. So we had a couple of DNS errors, but most of them were HTTP. And finally, down here, we have a latency histogram, and you can see most of the requests, which was 1,500 something, were around 0 milliseconds. So that's good, what you want. But somebody probably was very unlucky and had to wait. One request took 3.7 seconds. So that was a bit unlucky, and you should probably keep in mind or check out every now and then why something might take that long. And then we can jump into more stuff. So if traffic is encrypted or we don't understand the protocol, we can just show you flows. And flows basically are like number of connections and who is communicating with who. So that is basic TCP and IP information that we can gather. You can see which hosts are communicating, and then you can see which IP addresses with who and how much traffic. But if we understand the protocol, we can actually parse a lot of information from the headers of those requests. So for example, we would know like this was a request and a response. The protocol was HTTP. The response code was at 200. The whole thing took 150 milliseconds. And you called the URL foobar. And all of that can be extracted just from the headers. So let's see how that looks like. These are the HTTP requests. You can see when you joined, in doing requests, we got more of those. You can see in the last 15 minutes, we had 1,200 something requests. You can see which were the top URLs, and well, orange is not great for 200s. Let's make that green. Much nicer. So you see the most requested URL was the /good, which got 509 requests. Then we have the fav icon. You can see which errors happened. Down here, you can actually see the breakdown of which URLs were most commonly requested. And I can tell that you're a very serious crowd, because depending on who I talk to, I will get totally different things in here. Sometimes I will get like cuss words in there, or at some point somebody tried to push some, I don't know, Alfa Romeo car advertising. What people also tried is like, do we actually escape that? So at some point somebody tried to do a script alert 1 or something like that in here. Yes, we do escape that. You can try. But yeah, you can try multiple things in that URL, and it would all show up here. At some point, people have written like a small shell script and just did thousands of requests with some garbage. We can totally handle that as well. But yeah, you can just go around and experiment here. So that is kind of on the network level. Maybe, or on a mobile phone, it's probably hard to see. But maybe you saw that all the requests you did were encrypted, right? And I'm just using Let's Encrypt certificates. So it is a Hello World application, but I'm trying to keep it as real as possible. And previously I said, like, if the protocol is encrypted, we cannot really see the traffic. Like, where did I get that information from now? Do we break the encryption? No, we don't. So I'm basically running a reverse proxy in front of my application, which terminates TLS. And then I kind of monitor the traffic only between the nginx, handing over the traffic to my jar file. So that is where I sniff that traffic. So kind of I'm terminating 443, the port, in nginx, and then hand that over to port 8080. And that is where I extract that information from. And that is the only way you can actually do that, because if your protocol is encrypted, we cannot really see in it. But that is also kind of a feature that we cannot break your encryption. The other thing that might be interesting with packet beat is around security. If you have DNS, and you could actually tell which URLs were most requested, because there is stuff like DNS Exfiltration, where you just call a random URL to kind of push some relevant or security information out of your network by just calling random subdomains of an attacker-controlled domain just to exfiltrate some information. And here we would see like which URLs were most requested or which DNS entries. And you can see most of that was our domain. Okay, then we had Let's Encrypt.org, where the certificates are from. And then we have this found.io thing. Anybody knows what found.io is? That is actually the cloud service where we are hosting our Elasticsearch and Cubana instances. It was its own company, started in Norway, and at some point, we always say the company joined the family, so it joined the Elastic family at some point, but they're still using their found.io domain. That's why we have still found in there in the domain list. But you could like see how many requests were done and how many unique domains actually were hit on that. So that can be very relevant from a security point of view. The other stuff that you might be interested in is where else could we get information from? So since I said I'm using nginx as a reverse proxy, I guess most of you are familiar with the nginx access logs, var log nginx access log. And I'll jump to the end so that we can probably get some good requests here. Like that would be one good request. And you can see we have a lot of information here. So we have, it's slightly cut off, but that would be a full IP address over there. We have a timestamp. We have an HTTP verb. Okay, we got a fav icon, but okay. We got an HTTP version. The 200 is the response code, how many bytes we sent. Okay, somebody got more creative on the URL. That's good. You can just play around. And we got a user agent. So we got a lot of information here. And if you've used a kind of classic Alex stack, what you would do is you would take logstash and then point logstash to that file, and then you would need to write the regular expression to kind of parse that into the meaningful parts. And at some point we figured out this is kind of pretty tedious and nobody wants to do that. So with the beats to collect log files, we have a beat called filebeat, which is kind of obvious. It's just collecting files and forwarding them. We also have added now filebeat modules. And filebeat modules basically know for that application you want to monitor on your operating system, how is that working out? And it's kind of automating the work for you. For example, we have an nginx module for filebeat, and I just told filebeat, well, I want to monitor nginx, and then it knows, okay, on your operating system, Ubuntu 16.04, the log is in var log nginx access log, and that is how the default patterns looks like. And it will then collect that file for you, it will parse it, and it will even enrich it. And that enrichment will be, it will take the IP address and try to find the geolocation for that. So we'll see in a moment how good the geo-IP information is, which is sometimes good, sometimes not so good. And it will also kind of try to normalize the user agents. And we'll then see a breakdown of like which operating systems were targeting it, our site, which browsers, etc. So let's jump to that dashboard. So in the filebeat section, there will be an nginx access and error log. And that has just automatically collected that information here. And we can see, okay, that looks, well, maybe not perfect, but okay-ish. And then you can do two things. Either you can just zoom down and see what has been going on here. Let's try to zoom into that region. And depending on how good the Wi-Fi is, it will be faster or slower. And for some reason, yeah, the geo-IP lookup is not that great because it assumes most of us are in Stockholm, which is interesting. But yeah, some, like, we had 2,700 requests from Stockholm, but some are kind of around here. So yeah, geo-IP information is always kind of, it depends a bit on how good your geo-IP data store is, or database is for that. Only take it as an approximation where your data is coming from. Okay, you can see the breakdown of response codes. So you can see somebody did more 404s here. You can see the errors over time that we had. Again, we parse out the URLs that you hit. And we can see which browsers and user agents people had. So we can see quite a lot of Chrome. We have some Samsung here. We see their versions. And operating system-wise, we have a decent amount of Android. We have some Mac OS 10. We have some Windows 10, okay? And some iOS. Do we have? No, we don't have Windows Phone. Because normally I have one person in the room who has Windows Phone. It's normally only one. So that one is normally very easy to identify. But today, we're not that lucky, I guess. Well, and most of you, I can tell, have already updated to iOS 11, and only, I don't know, very few are still on 10. And you can see kind of the traffic that we're pushing around here. And we don't only have that for nginx, but we have that for systemblocks as well. So we have, for example, let's see the syslog one. So anything that your system generally logs out, we can collect, parse, and you can see, okay, which users have been doing it or logging what operations. And okay, this is mostly the DHCP information, so it's probably not interesting. What can be more interesting is like who has been running sudo commands. And I didn't run any sudo commands in the last 15 minutes, but see, over the last 4 hours, I ran, well, some sudo commands. Luckily, no sudo errors, so everything looks to be in order, and those were the commands I ran. The other thing I could check out is SSH logins. Did anybody try to log in with SSH into the nodes? No? Okay. No worries. Normally, somebody does it for you anyway, and you can see over the last 4 hours, you have errors. Let's make that red, because green is kind of like hard to tell. Invalid. Let's make that orange. And you can see the only ones accepted. That was probably me, and there were some requests here. So in the morning, I deployed my application and I logged in a few times. But otherwise, this was not me. Like these 20 invalid requests was not me. And you can see, okay, when were the successful requests, that looks okay to me because I was sleeping until, I don't know, 8:30 or whatever. So no requests prior to that, that looks good. And then you can see like which failed users were used. And you can see, okay, admin is popular, Adela is a new one. Like normally, okay, the domain name, support, user, Oracle, Informix is also creative. And you can also see where your requests are coming from. So normally Russia doesn't disappoint here, and you will get a fair amount of, but Russia is not doing that, is not that strong today. I'm kind of disappointed. However, China is doing well today. So you get 25 login attempts from China at some point. We could just lock that down to these Chinese requests. So basically I'm setting a filter here. You can just draw that down on that graph here. You see we have a limitation kind of like on the longitude and latitude. And we can see which users were popular or tried by China. And obviously Adela and Git and Informix have been coming from China. Interesting. Doesn't sound very Chinese to me, but okay. And then you can see, okay, what they tried, like which IP addresses and the country and everything. So that's all easy to try out. Okay, let's come back to our application. We got some 500s, and normally you will log them out, and you just want to see what is going on there. So what you will normally have is, I think I put that into apps, and the application is called front end, and we have a classical log, and you have something like this here. So you have some information here, and if you scroll down, probably at some point we have some big stack trace like here. And you can totally log stuff out like that, and it's kind of readable for humans. And yeah, my message was, this is indeed null, and then at some point deep down here I throw a null pointer exception. But to make use of that in Elasticsearch, you will kind of need to parse that back properly, because you have a lot of information again here, and I'm trying not to fall off. You have a date here, you have the error code here, you have the application where you run that, you have something like a thread information, you have what actually happened, and you would need to parse all of that. And that's again kind of a lot of annoying work to parse that back, and especially those threads. Like these lines should not be independent log messages. They should still depend or kind of belong to that actual error which you have been running. So what do you do here? You could parse it back, but it's kind of like a boring work, and I don't try to do that. So my application is logging out directly to JSON as well. Let's go to the bottom, and that is probably our stack trace here. So here we have everything in a structured format already. So you can see the name that somebody was using was that. Somebody was typing a lot, actually. You have like the timestamp nicely extracted, and you have all of that information in kind of a structured way. And then you don't need to do any cumbersome parsing anymore, because you can just take that, since it's JSON, you can throw it into Elasticsearch, and Elasticsearch can store that, and you can just see what is going on there. So let's jump to the Discover view now, where we can actually see the independent documents. And let's take a look at one of these documents. So what we want to do is, we have an application here. I will filter down to that application. because otherwise you would have the nginx access logs and the system logs and everything in there as well. So I'm just limiting that down, and maybe 4 hours is a bit too much, but okay. We had our Java application had a few thousand hits, like 2,400 hits were in our Java application. Let's say we only want to get the last 15 minutes of that. And what you can then do is, so these, you can see this is where we were doing more requests, so we got more logs here. What we can then do is we have all the fields that were in there are nicely parsed out already. So JSON is just from the original JSON message. And what would be interesting now is the severity. And we have a lot of info messages and a lot of error messages. And I'll say I'm only interested in the error messages now. So I will filter down on those as well. It's filtering down in the background. And it will then tell me, I don't know, will be not 1,500, but okay, around 90 errors we had in here. And you can see, okay, we're logging that NDC information, so that parameter that you're passing, I'm logging that out explicitly as well, so you could access that. And then we have the entire stack trace. We also have some meta information. So automatically, that is, the beat can do that automatically for you. It will figure out, for example, it's running on that AWS instance, and it's a T2 micro, and it's running in EU West 1. So it will automatically enrich that with quite a lot of information, so you can actually filter down to a specific instance or connect that to your AWS console as well. And the final thing that is pretty nice here is that stack hash. Basically, what we're doing is we have the big bad stack trace here, and at some point you probably want to figure out like how many unique stack traces do I have in my application. And what the stack hash is doing, basically throwing out all the things that change between requests and throws them out, and then hashes the rest of the message. And that normally uniquely identifies one specific stack trace. So let's see how many stack traces we have in our system. We don't have a pre-built dashboard for that. We'll just put something very quick together. I'm just using a vertical bar chart. This is a file bit information, and I just want to see, I want to do a term again, and the term I'm interested in is that stack hash. And I say, give me the top 15 stack traces I had. And you can see here, we had that one stack trace 32 times and that one once. So you probably know which one to fix first. So probably this one is the most relevant one. And you could then, for example, say, I don't know, let's break that down, and I'm not sure I have great information on that, but I don't know. Let's say we have some thread information, and to know which threads were affected by that, or which user, if a user is logged in, or whatever information you have added to that, you can just filter down and then see, okay, how many users or whatever were affected here. So you could totally do that. The next thing you might be interested in is to know is like, is my application up or down? And we have another beat for that, which is called heartbeat. And we have a nice dashboard for that. And heartbeat is basically a pinger pinging your services every, I don't know, 10 seconds, I think I have set it to. And you can see all these services are being pinged, and you see all of them are green. You can see how long does it take to establish the connection, and that is actually broken down in TCP, HTTP, TLS information, plus the DNS lookup. And you can see what is slow and what is taking how much time. We have that heat map where you can see, okay, most requests were around 50 milliseconds, but some were, like, there was one request which took 450 milliseconds, which is kind of slow. And you could just dive into that and see what is going on now. And we could just kill a service now. Let's quickly do that. Java or nginx? Which one should I stop? Java, okay. Let's kill the front-end application. So what will happen is the pinger is running every 10 seconds. The refresh rate is set to 5 seconds, so it will take around, I don't know, 20 seconds or so. Or it can already see, okay, service is down. And you see you get a 502 back. So that is actually, should be a bad gateway, I think, which you should get. So if you refresh that page, and since it cannot reach the backend service, it will just give you a 502 back. If you killed nginx, you would get a different error message here. You could already tell from the pinger what is going on. Let's quickly start it again, because I think that takes about 20 seconds to start up. Then the pinger needs to pick it up, then the page needs to refresh. So at some point, this will kind of refresh again here, and you will see it's up. But maybe we don't want to wait for that. We can jump to the next thing we can do. One other thing that might be helpful is once the application is up, probably you have some endpoints which you can use. So for example, we have health, and that will answer with something. Or we have metrics, which will give you some information. And if you want to try it out, that is, I think, admin and secret are the credentials I've used here. And it would tell you about, I don't know, heap usage, number of requests, all of that information. And since this is JSON, we can again just collect that. And I'm actually collecting that in two ways. So one, the JSON endpoint, and the other thing is, since it's a Java application and Java supports JMX, and JMX is kind of popular there, we can also collect JMX information. And then you could just collect that and visualize it again. And not to bore you too much, I will just jump to the visualization right away. So once again, I'll use the new visual builder, and I say, okay, I want to visualize my heap here. So what I want to do is I want to see the sum, and the sum of my field is Jolokia, metrics, memory, heap, usage, used. Once again, let's switch that over to bytes, so we can actually see what is going on. And then you can see I want to break that down to a specific node. And you can see the typical Java process, like you have a garbage collection, then your process runs, allocates more, then you have another garbage collection. Here you can actually see we have stopped the front-end instance. So if I just filter down to that, this is when I stopped the front-end instance. And you see it was gone, and then we started it again, and now it's using memory again, but it wasn't doing anything. The final nice thing that you can do here is you might want to add some information about if something changed. So for changes, we have two things I can show you. The first thing is we have a brand new beat called audit beat, which is basically auditing your system, both on like kernel messages, but also file changes. So we have this graph here, and I didn't deploy in the last 15 minutes, so let's switch back to the last 4 hours where I have deployed. And basically it will tell you files changed. And what I'm monitoring is the directory where my application is being served from. And it would then tell you, these are the locations where something is being served from. So I always put my jars into opt, and it will tell me, okay, these are the files that changed. And you can actually see which files changed. Like we modified the access, we created a file. You could really see what is happening to your file system and if anything in your application changes. The other thing that can be very helpful is since I deploy everything automatically, I can write out events. And what I want to see here is I have events, and I just want to show these events. This would be one deployment event. And it would be cool if I could annotate that in my graph to actually show me when something changed. So whenever I change something in my instance, I will just log it out. So for example, Ansible ran here, and it says I changed the monitoring instance, and that was the host. And the user who did this was this. So what we probably can do is we have application system user is probably a good combination. So we can annotate that and say, I want to take stuff from my collection events. We said application system user, and then we can say user deployed application to system. And since I didn't deploy in the last 15 minutes, let's switch that over to 4 hours as well. And you can see that was kind of my initial deployment, but we can actually deploy something live now. This is super small, but I'm just deploying my bad jar because this is super small and should be up in no time. So you will get, in a moment, you will get kind of like a new deployment event here. And if you hover over that here, you see Philipp deployed front-end to Java. And system is kind of, no, it shouldn't be system, it should be Java is kind of not helpful. That was the wrong label. But you get the point. You can just, whatever you have written out in your event, you can put in here, and then you see who deployed what when. And then you don't have to run around the office to shout, like, who destroyed the application? What did you do? But it will actually tell you, and you can go to that person directly and say, like, fix it. The final thing you probably want to do is tracing. So there is Zipkin. Since we're running short on time, I guess I don't want to go too deep into Zipkin. Basically, what Zipkin or Sleuth is the library that does is the first time your request hits the system, it will get a unique ID. And then every request as it's going through the system is keeping that ID, and we're kind of seeing by that how it's kind of like walking through the system. And that is also the best way to find out, like, if somebody says your system is slow, that is normally a very hard question, because it's very hard to find out like what is slow, where is that slowness coming from. So I want to, let's do a slow request here. Get a slow 200 with the background task. So that should take some time. That is the Zipkin UI. You can tell this is made by backend developers, and the UI is not very polished. And you can see, okay, here this request had 3 spans, so it called 3 things, and it took 4.7 seconds. So let's see what was going on here. And you can see we called metrics, and it called parent metrics, and that took forever, and then the actual metrics call was very short. But metrics is probably not a good example. We can take a look at that. Also 3 spans, and you can see we called something, then it was calling slow, and then it was calling slow call. And here you can actually see where it spent its time. Like here, okay, it took some time here, but most of the time was spent in here. So that is probably the first thing you want to debug for slowness. And then you see this call was very fast, and then it was just giving everything back. So here you would basically see what is calling what and where it's spending its time. And I've cheated a bit. It's kind of doing a random sleep. So that is where the slowness is coming from. But you could actually see what is going on here. And actually, I'm logging some background information here so you can see which services are being called. And since this is the slow thing, if you click on that, it actually tells you, okay, here I called a background sleep 483, so you can add or annotate additional information with that. And that's how I can just debug how stuff is going. And Zipkin has different backends where it can store its information, and one of them is Elasticsearch again. So we have all of that information in Elasticsearch. Okay, since we're pretty much out of time, let me wrap up. So, wherever I put my clicker. I always compare this a bit to Lego. Like you have all these building blocks, you need to do some assembly yourself still, but it's kind of, you can build everything. And if you want to get kind of a quick start on building stuff, just take a look at the repository to see configuration files and how to put everything together. Yeah, this is kind of what we looked at. We saw system metrics, file beats, the auditing. We checked out the application logs. We saw uptime monitoring. We checked out the metrics exposed by the application. And we did request tracing. And this is kind of the one slide. If you want to try out stuff afterwards, if you want to see the dashboards and play around with the dashboards, they are available at cubana.xera.wtf. And this is where the code lives. So this is kind of the one slide you can take home. So you can both play around with the dashboards, and you can just check out the code if you want to. And one final slide. Are there any questions? And before you run off, I have a bunch of stickers over there. So if you want to have any stickers, grab stickers. Normally, I try to take a picture with you so I can prove to my colleagues that I've been working. Since nobody knows where I am today, it's very dark here, but let's try. Try to smile, everybody. Okay, that will do. So people believe me that I've been working. So, who wants to go for lunch? We're done. Who has more questions? Either get started in public, or I'm also happy to answer in private afterwards. Any questions?